Hi, my name is Siravich. Me and my partner Ruiyu will be talking about job resume matching. First of all, I would like to talk about the motivations towards this project. So we are interested of the recruitment process, and they would use something called the application tracking system. So the system includes a list of job postings and the candidate that have applied, for instance, at a company website. So we have two databases of resumes and candidates. And the recent version of the application would have the feature of searching through everything. So typically the candidates and looking into the resumes and seeing if some set of terms would exist in someone's resumes. So our question is, can we automate this process without having the recruiter subjectively choose terms and searching everything? This is an example. So the term Java SQL and database was search, and the search result will include the resume listed ranked by the most relevant resume, so one that has the most occurrences of such words. So in this project, we look at two scenarios. One is that we have a single job posting and we wanted to have a list of resumes of candidates who would be qualified for that job. And the other one is having someone's resume and seeing if this person should be applying to which job. This presentation can be broken down into four major components. The first is the data acquisition, how we got the resumes and the job descriptions. Then we pre-process the data, and the matching has two scenarios as mentioned before. Finally, the evaluation. On data acquisition for the resumes, we have a website that has a folder of many resumes, and we use the httrap website copier to download everything in this folder basically. And the other data set we acquired is from Kaggle, which is the human resource portal career center. These are the job postings. The members on Kaggle managed to scrape off the data from the website and made a well-structured CSV file containing these elements. And what will be interested is the required qualifications highlighted as shown here. And back to the resumes. So there are files of PDF and a Word doc. We basically converted the Microsoft Word documents into PDF using an upload online batch tool. And finally, we get a list of PDF files. Then we run this small script that would iterate into each PDF files and generate the text that exists in the PDF. After we get the list of text files for each individual resumes, we combine them so that every text in the resume would be fitted into one single line.
This is Ray, and my job was to match one resume and multiple job descriptions to find a best fit for that specific candidate. So the first step was to extract 15,000 job descriptions and download one web developer resumes from India.com. After convert the PDF into a text file, we apply two approaches to get similarities. So the first one is TF-IDF, but the limitation of TF-IDF is that it's a back-of-word approach, so maybe not well fit to document similarity. And we also tried the second approach, which is doc2vect. Doc2vect is an unsupervised algorithm to generate vectors to document. The doc2vector captures similarity between the documents and it converts each document into vectors. As a result, a semantic similarity can be captured by the cosine distance. To train the models, we identify several parameters. So the size equals 300, the windows equals 10, and the minimum count equals 5, and alpha equals 0.025. So So which means, so the size here means the dimensionality of the feature vectors. The windows means the maximum distance between the current and the predicted word within a sentence. And the alpha means the initial learning rate, while the ITR iter means the number of the iterations. However, it seems Dr. Vector was not a good fit, since it doesn't make sense that the technical support or secretary is more similar to the web developer.
Now we look at the scenario of listing out the candidates who would be likely to qualify for a job. First of all, we would have to make the term frequency matrix using the skitlearn package. From that, we get the 8,879 terms, which is considerably large. So we do the single value decomposition to reduce the complexity. From setting the number of components to 100, we can draw a scree plot as shown in this graph, and we would determine the number of components to be 60 because at this point the graph gets stable. However, after doing SVD, we do the dot product on the query, and it takes a very long time. So I have to find another approach in the next slide. I changed my approach to the truncated SVD by the skitlearn. It has a fast randomized algorithm to do this, and from the matrix, I can just calculate the distance using the cosine similarity of the query and the matrix. Now we look at the real example. So after doing the TF-IDF, we have the job right here. And after we transform the job into the terms, we would get the list of important terms. So what makes sense here is ASP, audio, JavaScript, TCP, and so on. The other terms are subjectively not relevant. And from applying this query to the TF-IDF matrix we set aside, we would have the list of candidates who would likely to be qualified for the job. And as you can see here, the topmost candidate is the only one that has the ASP. In this case, it should be the programming. And the other term is maintenance, which is not in the important term mentioned on the left side, but it should be somewhere down there. And you can see that other candidates would have this term in their resume, but they would not be ranked as the first one because ASP is more important. So some final thoughts on this project. I think it is considerably hard to measure the performance of this because it is very subjective. And in the real-world application, I think the recruiter would select the candidates for an interview, and in this process, they would have something like active learning, or like semi-supervised, where the candidates who were invited for the interview were flagged as a qualified candidate. What can be done in terms of improving on what we have right now here is, for instance, stemming. So having, for example, programming and programmer to be in the same weight, or we can consider other columns on the job description, or we can evaluate a list of skills that would boost the weight up. So for example, something that is very rare, like BMC software skills, would have a higher weight.